Okay, so what is the chaos theory? Generally speaking, the term chaos theory means that any insignificant change in a large system can have huge consequences, and it's also known as the butterfly effect. Chaos is a very complex topic, but specifically has to do with the small changes that result in big effects. So, small changes in initial conditions create vast differences in the final outcome. So, this is known as deterministic chaos, which means that the system is very dependent. It's like very sensitively dependent on the initial conditions. So, an example would be in the weather. We don't have perfect measurements of every variable, and the variables behave in the way we expect them to. So, we know the general outcome, but it's still highly unpredictable.
Okay, so Edward Lorenz, he was the guy that discovered chaos theory while he was studying weather patterns. He expected the difference in his outcome when he changed it from 6 decimal places to 3 decimal places. He expected the outcome to only have a small difference, but it actually caused a really big difference, which was surprising to him because he only changed like the decimal by a few places, but it still resulted in such a large outcome. And this is why we aren't able to predict the weather more than a week in advance, because all those changes add up and cause it to be a great outcome. So it's really unpredictable what will actually happen without knowing all the specific factors. And he developed the Lorenz attractor as a way to visibly show his chaos theory.
Okay, so the Lorenz attractor, a Lorenz attractor is a set of chaotic solutions, and it's also known as a strange attractor simulation. Lorenz put 3 very similar numbers into a chaotic system and began to observe the results. So the 3 started out pretty much on the same path, but they eventually strayed into like completely different paths, and they never overlapped. But they still stayed in the same general shape. So this differentiates chaos from randomness. And the shape of the Lorenz attractor somewhat resembles the shape of a butterfly, which is where the name butterfly effect comes from. And this is like different examples of it.
So in these pictures, you can kind of see how it looks like a figure 8 and how the paths never like come together to form one path. They're all separate paths, but they make the same pattern.
Okay, so Henry Poincaré. Poincaré studied the 3-body problem, and the 3-body problem is a problem to determine the motion of 3 masses, and the one that he used was the sun, the moon, and the earth, with nothing influencing them except for gravity. And while he was studying this, he determined that this problem was unsolvable because even though they all like are in the general same direction and like the same outcome, it behaves unpredictably.
So Benoit Mandelbrot, he came up with the idea of fractals, which are patterns left behind from different systems. And the basic pattern of fractals is always pretty much the same. His fractals make it possible to describe certain chaotic behaviors, for example, the stock market and astronomy and economics.
Okay, so this is like an example of the different of what like the fractals look like. Okay, so examples of chaos theory. So some examples are the weather patterns, cloud dynamics, epileptic seizures, heart fibrillations, neural processes, chemical reactions. Another big one is free will and consciousness, and then population dynamics and stock market fluctuations.
So we wrote a little story on how chaos theory impacts our everyday life. So this is Pamela. Pamela grew up in New York. One day she saw a little hurt pigeon stuck under a piece of trash, and she decided to save the pigeon. And unknowingly, Pamela was being watched by a member of the Humane Society who went over to Pamela and asked her if she would like to be a part of the Humane Society. She began working with them and gradually worked her way up to being the head of the organization. In her lifetime, Pamela helped to save thousands of animals.
Okay, but what happened if Pamela had chosen to walk away from the pigeon? Then she would never have become the head of the Humane Society, and thousands of animals that Pamela helped to save may not have made it. Because of this one decision that she made using her free will, Pamela not only changed her own life, but also the lives of those thousands of animals that she saved.
So how does Pamela relate to chaos theory? Free will is one example of chaos theory in everyday life. Life itself is a chaotic system. Think about Pamela's decision as a path on the Lorentz attractor. Pamela's seemingly insignificant decision sent her down one path of the infinite amount of paths she could have taken. The path she went on by her one decision led to an outcome that was drastically different than if she had made a different decision.